Hey everybody, before you get started on your first major lab for the year, I just wanted to spend a little bit of time and introduce density. So what is density for really? For real. Density is the amount of stuff that an object has in the space that it takes up. Okay, so remember that matter is anything that has mass and takes up space. Well, by that definition, everything that is matter has mass and volume and therefore has a density, no matter how big or how small. Now, when we're talking about density in kind of out in the real world, real life, and not just in chemistry class, typically when we say something is heavy or heavier, we're saying that because it happens to be more dense. It is heavier than we expect it to be for the size that the object is. So, typically, heavier objects are objects that just have a greater density. And then there's that old joke, which weighs more, a pound of feathers or a pound of lead? Well, they both have the same mass, they both weigh the same, they both weigh a pound. But people are inclined more to say that the pound of lead is going to weigh more because it is more dense. So a pound of feathers will take up a whole ton of space, whereas a pound of lead takes up a really tiny amount of space. So it's really like a trick question. I remember my dad giving me, saying that trick question to me when I was young, and I was all full of myself saying, "Oh, of course it's a pound of lead," but then it's a pound and a pound. So it's just that lead is more dense. Okay, well, let's take each quality individually, and so we'll start with volume. Volume is how much space something takes up, and so we can either use a graduated cylinder or a ruler in math. But look down in the corner, and you will see a couple of blocks. These I picked because they're different colors and they're kind of easy to see. This is an acrylic block, and this is made out of copper and aluminum, and this is iron or steel. Okay. Now, all of these four blocks have the same size. So what do we do in order to determine the size or the volume of this? Well, all we have to do is get a ruler out and measure the length, the width, and the height. Now these are cubes, so it makes it pretty easy to do length times width times height for these. Okay, let me get this out of the way. And then I can do, hopefully it stays in focus, I can do 2.50 centimeters, and that's the length. And then I can cube that, okay? I can cube the whole thing, and when I do that, I get that the volume is equal to 15.6, and we cube the unit too, so it's cubic centimeters. And so that is the volume of those cubes. Now, if you had an irregular shape like a rock, or if you had a liquid, you could measure the volume using a graduated cylinder. But with these cubes and with the lab, you're going to have regular shapes that you can measure just using a ruler and then doing calculation to figure out what the volume is. To measure the volume or the mass of something, we're going to use a balance. Now this balance here, you'll see, it's the one exactly that you use in lab. Okay, I have it open. Now remember, anytime you use a balance, you can't put anything directly on the balance pan. And so there is a, right there is your weighing boat. And then what we can do, and I would suggest you do it too, is we can find the mass of these things by merely putting it on the balance. So the first thing I'm going to do is zero the balance. It goes to 0, and now we can find the mass of the acrylic cube. Okay, and then we find the mass of the aluminum cube. Okay, 44.95. And then we find the mass of the copper cube. 146.25 grams. Keep in mind the units. Every number has units. And then the iron, double check that it's in balance, so that's good. And so there's 128.08. Okay, so now what we have is all our masses and all our volumes. So now that we have the mass and the volume, what we can do is we can take this guy, the acrylic guy, and then we can determine its density. Well, density is the amount of mass it has per unit volume. So the formula, that written out as a formula, would be D equals M over V. Density is mass over volume. And then we can just plug our numbers in. The mass of that acrylic was 19.82 grams divided by 15.6 centimeters cubed. And now we can plug that in our calculator, 19.82, okay, divided by 15.6, and that gives us 1.27. Remember to use sig figs. This has 3 significant figures right here, and then you report it to 3 significant figures. The 4th place is a 0, so you just chop it off, and then it's grams per cubic centimeter. Okay. Now for aluminum, we follow the same thing. Density equals mass divided by volume. Okay. Well, mass for the aluminum was 44.95 grams divided by the same volume, 15.6 cubic centimeters. And so now that volume, 44.95 divided by 15.6, that density is 2.88 grams per cubic centimeter. Okay, for copper you can kind of do the same thing. You just keep doing the same mass over volume. The mass of the copper was 146.25 grams divided by, let me push this up just a little. Okay, divided by 15.6 cubic centimeters. Okay, and so now we put it in the calculator. 146.25 divided by 15.6, and you get 9 point. Let me move the calculator. You get 9.38. Okay, rounded up, 9.38 grams per cubic centimeter. Okay, now take a minute and see if you can do the copper or do the iron one all by itself. Okay, pause the video, do whatever you need to do. The iron answer is going to be 128.08 divided by 15.6, and so that answer is 8.21 grams per centimeter cubed. Okay, so it's going to be, so this guy right here has a density of 8.21 grams per cubic centimeter. Okay, so the heaviest one is the copper one, and then the next one is the iron one, and then by far and away these two are the lightest. So put them in order. So this is the lightest. Okay, and I'll put that in quotes because it's not really the lightest, it's just the one with the least amount of density. And this copper here is the one with the highest density. Okay. So I hope that helps clear up what density is and how you're going to calculate it and how you can calculate it. Good luck.